So today I'm going to be going over homework 7, class and object. We're going to just go ahead and jump straight to problem 1. Problem 1 asks us to create an account object that has an ID, a balance, an annual interest rate, a withdrawal, and a deposit. So I went ahead and implement that. It says they want to set the account ID to 1122. Then I did. It says for the balance to set it to 20,000. I did. It says double and ECN, but it gets implicitly casted, so it's fine. Annual interest rate, it says to set it to 4.5. So I did. Withdrawal amount, I set to 2,500. And then for deposit, I set to 3,000. Okay, so this line here, basically we're instantiating an object called demo account, and we're basing off of on account class. To instantiate it, we're going to pass in the account ID and balance. And then once we did and create that class or that object, then we're going to go ahead and call a couple of methods. We're going to set the annual method interest rate to a number, so we pass in the annual interest rate to it, and we're going to modify it. And then we're going to withdraw, and then we're deposit, and then we're going to output our results. So I went ahead and did headers, and headers basically are how or what we're going to be using in our class, like what variables it's going to have, what methods. Essentially it's going to establish its signatures for those methods, what's going to be private, what's going to be public, and then in the CPP class is where we actually implement those methods. Okay, and of course constructors as well. So for the header, we're going to have 4 private variables in struct. The 3 variables are ID, balance, annual interest rate, and then we're going to have a date created, which we're going to use in a struct format. So just to go ahead and use it, I have the header for that as well. We're going to be having like 3 variables and 3 methods. The 3 variables are day, month, and year. And then for the 3 methods, we have the date, which is a constructor, and then a no-args constructor at that. And then we're going to have a specific constructor with 3 parameters passed in. And then we're going to have a method called getDateCreated. And so when we're implementing that class, this is what it would actually look like. For our no-args constructor, we're going to be using some packages where it gets the time right now, what's the day right now, and then it updates the year, month, and date to that respective. And then we have the date constructor, which has the 3 variables that we are going to be passing, which all has an int type. Grabbing those parameters, and we're setting to the initializing those 3 variables from our class that are privated. And then here we are creating a get date created, and it's going to return a string. And to do that, we're going to use the string stream, and we're setting up this format to retrieve in the format of month, day, and year, since that's how we do in the US. Okay, so let's go back to the account. So that's it for private. Now everything in here has a public modifier. This line right here is just a no-args constructor for account. And then here is another constructor, but we're passing in 2 parameters. We're passing an ID and balance. And then here we're just creating a destructor, and this is in the case of if we have some things that we want to clean up from memory after the object is vulnerable to being deleted. And here we're having some accessors, also known as getters. Essentially, they retrieve the certain variable that are being private. This is an example of encapsulation. So with this method here, we are getting ID and returning it as an int. We are getting balance, returning it as a double. We are getting annual interest rate and returning a double. We're getting the monthly interest rate and returning monthly interest rate as a double. We're getting monthly interest, and it's going to return a double. Now we're going to be talking about mutators. Sorry, talking about mutators here. We have a few mutators. We have the set ID, set balance, set annual interest rate. And the idea of a mutator just modifies those private variables to a new value. So we are passing in the value, the variable that we want to change it from. And so we're not returning anything for these setters. So here it modifies the ID, here sets the balance, here sets the annual interest rate, and that's it for the mutators. So, and then our last three variable or methods are withdrawal, deposit, and output. The aim for a withdrawal is to, by the way, all three of these don't return anything. Neither do the mutators. So the withdrawal, you have to pass in an amount. Same thing for the deposit, you also pass in an amount. And the idea is that this amount is what the user wants to withdraw from. So if they want to draw $2,000, they can, and they have to pass in that amount. Same thing with a deposit. And the outcome of the withdrawal is supposed to subtract from the balance, and the outcome of the deposit is supposed to make the balance increase. And then the output just displays the ID, date created, and the balance. Let's show how we actually implement those. So here we're automatically using the no-arg constructor and setting the ID to 0, setting the balance to 0, setting the annual interest to 0, because that's what the problem stated. Then in this right here, this one is a constructor that has two parameters passed in, ID and balance, an int and a double, and that's its signature. We're gonna update the ID and balance of those original values that we have for ID and balance, which was 0. Then we have the destructor for the account, and this is for setting the ID and the balance back to 0 in case if it wasn't, because we're destructing it, aka deleting it. Now we are going back again to the getters. Now to actually do it, we are returning the ID, which is an int, returning the balance, which is a double. But for get annual interest rate requires us first, remember the monthly interest rate in the problem stated 4.5, but that's a percentage, right? We're going to convert it into a decimal, so we're going to divide it by 100. And then because it's monthly, we have the annual interest rate, and we have to divide that by 12 since there's 12 months in a year. And we're returning that. Then we have the get monthly interest. So to calculate that, we have to get the monthly interest rate, which is what we just discussed here, and then multiply it by its balance to get the get monthly interest. And then get annual interest is we just return it. This is the variable that we have in the private. Same thing how we did for ID and balance. So it's going to return a double. And then here, the problem stated we have to have mutators. So this is how we mutate. We are modifying those variables. This is where we want to change an ID. This is where we want to change a balance. This is where we want to change annual interest rate. Okay, and so now withdrawal, we have to do a little check. So when they pass in the amount that the user wants to spend, we have to first check to see if it's less than the balance. If it is, they can't really withdraw. They have to make sure the balance is at least equal to or more than the balance. Okay, but let's say they do have enough, they have sufficient funds in their account, and then we can proceed and actually subtract the amount from the balance. And then for the deposit, there is no necessary for checks. We just need to update the balance to the addition that they wanted to deposit the money. And finally, here we have the output. The output aims to print out a couple of things that we wanted to print. Problem wanted us to print balance, monthly interest rate, and the date when this account was created. I threw in the ID just to show that it's been modified, and let's go ahead and run it. And that's good. For problem 1, we got an ID of 1122, and we have the balance is 20,500, and the monthly interest rate 76.88, and then that is the date that it was created. Awesome. So just to briefly go over the UML for that, what it looks like is this. These are private variables and methods you can actually put in. And then here's our public. So anything with a minus is private, anything with a plus is public. And so as you can see, the account, there's an ID, balance, annual interest rate, and date created. And then for date, there's month, day, and year, and this is a struct. So these are the methods that it had, and this is how it's presented in UML format. So now we're jumping into problem 2. We're trying to figure out the quadratic equation, and figure out the discriminant and whether the discriminant has some roots or not. And to do that, we need to go ahead and establish the what our variables a, b, c are. These are coming from the user. We're going to say, hey, give me the value for both a, b, and c, and then we update those values based on the users right here. And then we're going to go ahead and instantiate that object using the quadratic equation. The name of the object is person1, and we're passing in those variables that it gave us. And then in the next line is that we are actually we're using person1, and in the quadratic class there's a get discriminant, and we store it into the discriminant variable, which is a double. And then we're going to go ahead and check to see if the discriminant is positive. If it's positive, it has 2 roots, and then we're going to compute the roots here. If the discriminant is 0, then we'll go ahead and call just the root1 function, get it printed. Now let's say that this discriminant wasn't positive and it wasn't 0. By default, this implies that the discriminant was negative, and so we just simply print that the equation has no roots. So just to go ahead and cover what that looks like in code, we have some private variables a, b, and c, and these are private variables. They're automatically set to 0. And then these are the public. This is the constructors right here. All 2 of them are constructor. This is a destructor. This is a no args constructor. So by automatically, when we created that object, this gets run. We're not passing in no args because that is why it's called no args. Then here we are manually creating the quadratic equation that's going to take in 3 parameters, and they all have to be doubles. Then we have our getters, which are also called accessors methods, where we're retrieving a, b, and c, all of them returning a double. And then we went and go ahead and actually have these formulas. So these methods here, we are getting the discriminant, and we're going to calculate that. We're getting and then returning a double. Then we're getting root 1. We are calculating root 1 and then returning a double. We are getting root 2, and we didn't get root 2, but we're going to calculate root 2. And these are going to be used in the main like what we just mentioned. So if we close that, there we go. Quadratic equation actually being implemented looks like this. So we have the no args constructor. We're just automatically going to set everything to 0. And then we are going to, once it gets instantiated, the object, we're going to pass in 3 parameters, and we're going to update a, b, and c with its respective variables that the user wants into these guys. Then this is the destructor, so we use this in case if we wanted to delete something like I mentioned in the previous problem. And then here we're having our accessors. So the idea of the accessor just retrieves the values of those private variables. So we're retrieving a, b, and c, and it's going to be returned as a double, double, and double. Quadratic equation, here we're using what's called get discriminant method. This is just us calculating what's the discriminant. To do that, we have to use the variable b squared minus 4 times a times c, and it returns that double. This right here is how we calculate root 1 and how we calculate root 2. This is the formula for root 1. First, we have to retrieve the discriminant and then use that to calculate root 1. Again, similar to root 2, except it's for root 2, and we're making it negative instead of positive. That's the difference between root 1 and root 2. So both returns a double. Awesome. Let's go ahead and show that in action. So we have a test here. let's say that we want, to use 1, -3, and 2. It should be, by here, the answer should be 2 roots, and they should be 1, 2, and 1, which is correct. Awesome. So now to problem 3. So problem 3 asks us, hey, we have a line. And what establishes a line is that there's 2 points. There's a beginning point and an end point. With this line that has 2 sets of coordinates, we want to see if it intersects the second line. So it has another 2 sets of coordinates. So there's 4 coordinates in total. We want to see what is the point that they intersect, or do they? And so this is where we check to see if they intersect. So it's going to, this double, essentially we're instantiating all the 4 coordinates at the same time, where we are getting the user's x1, x2, y1, y2, up until x4 and y4. So, and this is us retrieving the users and updating that value. And once we do, we're going to instantiate a variable called line1 that's being created from a class called endpoint. And we're passing in those variables, and then we're going to call the display intersection to check to see if it actually is intersecting. So let's take a look what that looks like under the hood. This is my header class, what we want to use, what variables we want to use. And as I mentioned, we have 8 variables, the 4 coordinates, and then those are privated. And so the rest here are public methods. These 2 are the constructors, no args, that has no parameters. Here we have a constructor that takes in 8 parameters, all doubles. And then we have a destructor, which we'll go ahead and clean up if we want to. And then is on both lines. That is a method that returns a boolean. And here we're passing in 10 parameters, where we are passing the 8 coordinates, the 4 coordinates, and then we're calculating the x coordinate and y coordinate of where they actually intersect. This is to check, is those intersects on those lines. And then we're going to display it, the intersection, by calculating and displaying it. And it's also going to return nothing. So let me go ahead and wrap that for us. Okay, here we are actually implementing those methods. So we have the noargs constructor, and we have the endpoint. This is the destructor for this right here, this constructor. We're just setting those variables that it was given to us to the updated variable that was given those classes. And then finally here, we're just using a Boolean method just to check to see if that x-coordinate and y-coordinate exist on both of those lines. If it does exist, then it's going to return true. If it doesn't exist, it's going to return false. Okay, and this is the condition that I set to check to make sure, is the x-coordinate on the first line, and then to check to see if it's on the second line. Okay, for display intersection, I had to write some pseudocode here because I had to first calculate what is that intersected point, x and y, and I found that if I used the Cramer's rule that it helped me get there, and so this is my pseudocode for that. So here's me calculating the variables that I need just to find what's the x coordinate and y coordinate. And then I put it together using the Cramer's rules. And then in the if statement, I check to say, hey, is the x and y coordinates that I just calculated, I'm going to pass in the variables and then say, hey, is that that point that I calculated on both of those lines? If this rings true, then this statement gets printed and it prints the x and y coordinates. But if it's not, then it just says they don't intersect. So in the problem, it says, it gave us an example, and we're going to go off based on that example. So it did 2, 2, 0, 0, 0, 2, 2, 0. And with those 4 coordinates, it intersects at 1, 1. And so that is show the UML of the problem that I just went over. So this is what it looks like for this class. There are 8 private variables, and these are the methods. This is how you would implement it. And this is the UML for the second problem. There are 3 variables that are private, and everything else is being public. These are our constructor, destructor, and those get. Okay. So, on to the last problem. Problem 4, basically, we are going to be creating a 2D array. And this 2D array, we're going to try to locate the largest value in the array. Okay, to do that, we created a variable called row and column. Ask the user how many rows do you want, how many columns do you want, and that's going to be creating our 2D array. This is it. This is how we're going to do it. We're going to be creating a 2D array called array of nums, and we're going to go ahead and allocate the certain memory using the number of rows that the person inputted. Then here we have a for loop that allocates the memory for each of the column, but we do it within each row, which is why we're looping within row. Then here is me actively getting those numbers from the user and looping them through. That's why you get 2 loops, one for the row and one for the column. And then I will print out what the user inputted, and then we're gonna go ahead and instantiate that object called location1 using the location class. We're gonna pass in a row and a column, and then we're gonna actually call in the method called locateLargest, and we're gonna pass in the array of nums because that's how the problem was set up. And then after we've located the largest element in the array, we're gonna just go ahead and delete it so we don't, we can avoid some memory leaks. So I will go ahead and show you that code. Again, we have a header file here, and we have the 3 variables that we're going to set to private, and it's row, column, and max value. And that's just a check to see what is the maximum value. Then we have some public methods. Here we have a no args constructor. Here we have the constructor that only takes 2 inputs, the 2 parameters, which is int and int. And then we're taking another one, but this has int, and double, which takes in the row, column, and maximum value. And then we have the destructor, and then we get the maximum value. Okay. Here, we just get the maximum value, return a double. So I'll come back to explaining why we need this in the implementation process. But just know that we have a method here called copying array, and it's going to return the 2D array in a double format using a double data point, and we also passed in a 2D array. And then finally here we are actually I decided to sort it, and then by there we can find the maximum value. So here we're just returning a double, and we have to pass in a 2D array. Here the aim of this method is to just actually locate the largest array within the 2D array, and we're not returning anything, but we do have to pass in a 2D array. Finally, let's show the implementation process. So we have the no args constructor, and then for the location, we have row and column, and we're going to update the parameters using updating the variables in the class by the parameters that was given. And then we're going to have this parameter in case if the user happens to have 3 variables. I decided to include the third one, max value. Though this one really doesn't get called, but I decided to include it. Then we have the destructor. And then we have the get max value. The idea of get max value is to retrieve the maximum value. And that's a part of, if I show you the ML, it's a part of the private area. There's the max value, so we can go ahead and get that. Then we, so I'm going to skip this and come back to it. We're going to talk about this guy. Sort and find max value. Okay, we pass in a 2D array, And then we are creating a 2D. We're setting up a 2D array called B. And we're going to set that to call the copying array and pass in the A that was given to us. And then from this point on, you're going to see we're only using B. Why did I do that? So I realized at the end that I wasn't retrieving the actual location of the element. I was retrieving the location of the element of after it was being sorted, which modified its index. And that implies that we are modifying the original array. We don't want to do that. We want to make sure we were passed by reference, not passed by value. So we're going to go ahead and do a copy of that array. And this allows us to, this ensures that we're not modifying the original array. And so in the end, in the next method here, the locate largest, we can locate that largest element by sifting through the original array that is not being modified. So how it's done, it's basically like the 3-cup example. You have 2 cups, and so you have the double temp, and it's set to, we're creating a new 2D array, and we're having a row, and essentially we're literally copying element by element into this new array called temp, and it returns temp. Okay, so it's returning temp, and temp is B. And so here we're actually going to be sorting B, which, it's just a copy of A, and we're sorting it row wise. Okay, so in each row it's getting sorted from smallest to largest, and then that means the largest number in the last column is the largest number for each row. So then I'm going to loop through to see if the last number in each row, which one's bigger. And whatever's bigger gets stored in maximum value. And then it keeps looping through. At the end of this sort and max and find max value, it returns a variable called max value and returns a double. That's going to be important for later because we're going to be calling this guy and we're going to be setting it to max value. So again, the aim of this method is to locate the largest value. So we have an x and y here, and that just serves as our coordinates that we're setting them to nothing. And then the max value, we're calling that this function, and it's returning a double, so it's storing that double into max value. And then we're just here we are printing actually, you know what, we're no longer printing it. I'll take that back. We're actually looping through the rows and columns and finding to see if that max value matches matches the largest element that we found. And then if it does, stop and just store the I, which serves as the x coordinate, and j as the y coordinate, break out and print this. And this should return the max value. So let's say we want 2 rows and 3 columns, and we're just going to do 5, 6, 4, 3, 7, 8. Okay. And so based on this, you would see that 7 is the largest one, and it's 0, row 0, row 1. So it's first should be 1, and then it's 0, 1, column should be also 1. So its max value is at 1, 1. And that is it for today.